common velocity. Then you sum the two mass, 5 plus 7. So by the time I do this very well, I'm going to have 60 is equal to 12 v, the velocity. So the velocity becomes what? Becomes 5 meter per second. This is called the common velocity. This is the velocity of the mass 2 after the impact. So what happened here now is that the velocity has reduced. You can see it initially the mass 1 started with 12 meters per second, but as soon as it collides with the stationary body, because of the effect of mass, the velocity reduced. So the speed reduces, common velocity. So this is our common velocity. So that will be the questions to be taken under conservation of linear momentum under kinetics. Now, another aspect we're going to quickly look at is called the static mechanics. Static mechanics. The static mechanics. So we said the static mechanics. The static mechanics is a branch of mechanics that is focused on the effect of forces on static bodies. So the word static means bodies at rest. So when we're treating the forces that will act on bodies at rest, we're simply talking about static mechanics. So let us consider the tangential force acting on a body at rest. Tangential force acting on a body at rest. We're going to have, I'm going to draw a diagram. This is a body of mass at rest on a surface. Then you have this, the weight of this body will act downward, which is our W, is the same thing as what? Mg. Then a force is being applied here as P. Then you have what? The normal reaction of this body. The normal reaction of this body is R. And we also have what we call the frictional force. Now, for some of us, friction, when we talk about friction, we're talking about the force. Friction is a force that acts in the opposite direction of an applied force. Is a force that acts to resist, that is a resistance force that opposes motion between two surfaces in contact. Now I'm going to make some I'll just try to explain this. This is a block of mass. This is M. Now this force is the applied force. So the applied force is towards the what? Towards the east. So this applied force is towards the east. Now the frictional force must act opposite to that direction. So it must act in the opposite direction. That's why we have the frictional force going the opposite. And now for this body to be in equilibrium, that means both the applied force and the frictional force must be equal to 0. So this mass will not move. Now this normal reaction is the reaction of this mass on this particular surface in contact. That is the action of this mass on this surface in contact. Although we also have that the weight of this mass is also acting vertically downward. So we have that the weight is equals to mg. Now there are some rules that hold true for friction. Some rules that holds true for friction. One of the rule is the frictional force is equal and opposite. The frictional force must be equal and opposite to the applied force. What we're simply saying is this P must be equal to what? Minus F. And that is what we should